Hello, everybody. Welcome to the MVP Tech Bytes, where we talk about technologies from our favorite MVPs all around the world. And today we have Foteini. Foteini, do you want to introduce yourself?
Yes, hi, and hi everyone. I'm very glad to be here today. My name is Foteini Savvidou, and I'm currently studying electrical computer engineering at the Aristotle University of Thessaloniki in Greece. And I'm also a Microsoft Most Valuable Professional in AI. If you want to learn more about me, you can follow me on my blog sfoteini.github.io.
Great. Thank you, Foteini. So today I believe you have something very interesting to talk about. It's called like and visions and stuff like that. So do you want to share a screen and then maybe we could go through it?
Yes, I think now you can see my screen.
Yes.
Okay, perfect. So today we're going to talk about a very popular topic, which is vector similarity search. And we are going to explore the image retrieval functionality of the newest Azure Computer Vision service, which is now renamed to Azure AI Vision, as I think, and we will build a vector similarity search system for searching a collection of images using the Azure Cosmos DB for PostgreSQL database. I already introduced myself. What's the newest version of the Azure Computer Vision service? The newest version is powered by the project Florence, which is a state-of-the-art computer vision model that was developed by Microsoft Research. And Florence model is a large computer vision model which was trained on billions of images and text pairs and videos. It is a multimodal model because it supports both image and natural language tasks and can be used to perform several computer vision tasks such as object detection, classification, background removal, video summarization, and frame rotator, and can also be used for image retrieval, which combines the image and natural language capabilities of the models. Flores model also supports open hole recognition because it can be used to classify images in million categories without providing a training set, but can also be used to customize models and build your own object detection and image classification models.
Does this Florence Foundation model have anything to do with the Da Vinci model that the OpenAI model has, or are these two separate models?
It uses a language transformer which is similar to the one that's
Hmm.
used by OpenAI.
Okay.
This slide summarizes all the newest features of Azure Computer Vision 4, and the newest features are background removal, text captions, which produces captions for several parts of an image retrieval, building custom models for object detection and image classification, recognizing products, and summarizing videos and detecting specific frames within a video.
Okay.
Today we are going to focus on the image retrieval functionality. And before explaining uh, how image retrieval functionality works, let's go to the Vision Studio. Okay, so this is the Visual Studio. It is the UI interface of the computer vision service. Here you can explore all the services that are available.
Hmm.
And I will start with the image retrieval tools. Here you can select the resource that you want to use with the Vision Studio. You can either create a computer vision resource or a cognitive service resource. But the image retrieval functionality in Visual Studio is only available for cognitive service resources created in the East US region.
Okay. And this is
Uh,
basically portal.vision.cognitiveservice.com. So it's not the Azure portal; it's part of the portal Vision Studio portal, basically.
yes, it's a specific
Yeah.
portal for Azure AI Vision.
Yes.
So here you can select some of the available image collections. I'll go with nature,
Hmm.
and you can see the image collection here once loaded, and we will use some text queries to search this image collection. Uh, Azure Vision Studio suggests some possible queries. For
Hmm.
example, I can search images that contain sunset in the mountains,
Hmm.
and here you can see a list of the most similar images to my text query sunset in the mountains. And there's also a slider here you can adjust in order to show more images, but the results will vary. You will see images that are not that are least similar to your text query.
Okay.
And if you go the slider on the left, you will see only the most similar images.
Okay.
Let's try a more complex query like reflection on a mountain lake. And again, we see that Vision Studio and Image Retrievals APIs can understand my query and return images that contain a reflection on a mountain lake.
Hmm. One
So
question I have: these images that you see right now, are they generative images or are they real images?
they're images that are included in this collection.
Okay. Okay. So they're
Uh,
real images that are already included
yeah,
in not generative AI generating
no,
these
no,
images.
it's
Yeah.
not like DALI. It's
Yeah.
images that I add in the collection, and then I build a search engine to search these images.
Sure. Okay. Great.
You can also specify here a custom query. For example, I want to search if there are images that contains an elephant, and I get image of elephants.
Hmm.
Of course, I see here another animal and a tree,
Yeah.
but that's okay. I don't know what you can adjust manually the threshold of your application to show only results that are
Hmm.
similar to the text query. So that's the demo. Let's go back to my presentation and see how image retrieval APIs work. So the image retrieval functionality is based on the conversion of the images into vectors, and these
Hmm.
vectors are called vector embeddings. These vectors are high-dimensional dense vectors, each dimension of which contain information about our original content, which is our images.
Hmm.
And by converting our images into vectors, computer can easily understand the similarity between images. For example, here is an example of vector embeddings of text, but you can just think about the cat is an image of a cat. And so the words cat and kitten are semantically similar,
Hmm.
and the vector embeddings also will be numerically close. On the other hand, puppy is not semantically similar to cat, so we expect that the numerical distance between the vector of a cat and the vector of a puppy will be higher than the distance of the vector of a cat and the vector of a kitten.
Yeah. Okay. So if I'm correct, basically, cat and kitten are basically, we could see that from the numbers sort of things. They're quite close to one another, and the puppy is quite different. But how does the word cat converts into an embedded model sort of thing? Do we use the semantics of like the text analysis, or do we use some other kind of semantics?
We use neural networks, and
Okay.
each layer of the network contains information about a part of the image,
Okay.
and we use all this information to construct a vector. And this
Okay.
vector is member of a high-dimensional vector space.
Okay. Great. Thank you.
Uh, so I think we can see that in the next slide.
Yeah.
Here we have vectors in a two-dimensional space because it's very hard to
Hmm.
illustrate vectors in a high-dimensional space. And we can see here that the blue vector, uh, which is the vector of a cat, is more close to the yellow vector, the vector of a kitten, than the green vector, which is the vector of a puppy.
Hmm.
And in order to quantify the semantic similarity between two objects, we can use a distance metric to measure the distance between the two vectors.
Hmm.
Some distance metrics that are used in the search engines are the Euclidean distance or the cosine distance. And today I'm going to use the cosine similarity distance, which is the distance metric that is used by the Vision Studio.
Hmm.
And cosine distance is defined as the angle between two vectors, the cosine of the angle between two vectors,
Okay.
and is equal to the inner product of the vectors divided by the product of the magnitudes of the vectors. Okay, and how image retrieval works. Here is a high-level overview of the image retrieval flow that we follow. The first step is to convert the images that are included in a photo collection into vector embeddings using the Vectorized Image API of Azure Computer Vision.
Hmm.
And then we can store these vectors in a database, in a specific type of database that is able to handle high-dimensional vectors.
Hmm.
And this type of database is called vector database.
Okay.
And then when an application issues a query to our system, we use the vectorized test API to convert the text prompt into a vector embedding. And we use the search vector and the vectors contained in our database uh, to to calculate the cosine similarity, and then we can find the n top most similar images to the text prompt that we used. And also instead of a text prompt, you can use another image to search your image collection. And in this case, you can use the vectorized image API instead of the vectorized text API.
Oh, okay. So the other thing is basically like what kind of like you say talked about image vectors database sort of thing. What kind of database are there to actually use for image? Are there like Azure? I don't know. Can I use a SQL server or what kind of database do I use?
Yeah, that's a good question. Several databases announced recently and during Microsoft Big. And in our session today, we are going to use the Azure Cosmos DB for PostgreSQL database,
Mhm.
which enables vector similarity search through the PG vector extension.
Okay.
And this extension is also available in the Azure PostgreSQL database.
Okay.
And you can also use Azure Cosmos DB for MongoDB, uh, Azure Data Explorer, Azure Redis database, and you can also use the Azure Cognitive Search, which is now in public preview,
Mhm.
which is not actually a database, but it provides tools for building an end-to-end search system.
Okay.
So, and this is an overview of the application that we are going to build today.
Mhm.
We will use we will first use the vectorized image API to convert images into vector embeddings and then store these embeddings in the Azure Cosmos DB for PostgreSQL database. And then our application will raise a query, and if the user wants to search the image collection using an image, we will use the vectorized image API to convert the reference image into a vector, or if the user wants to use text to search our image collection, we'll use the vectorized text API to convert the text prompt into a vector.
Okay.
Then we will use a SQL query to perform search over our search index in the Azure Cosmos DB for PostgreSQL database. And this query will return the n top most similar vectors to our reference vector. This is actually a Jupyter notebook. I have already created the vector embeddings for the collection of the images, and I have saved these vector embeddings into a JSON file. And now I'll show you how you can store these vector embeddings into your database.
Okay.
Before going into our demo, let's go to the Azure portal because in order to use the Vinnci vector extension, you have first to enable this extension in your vector database.
Okay.
Uh,
So you would go to the Azure portal and then go to the create a vector database, and then like it's I could see that it's in a preview, and then you would get the sort of a console, and then you could type in the command for it.
Yes, I have created an Azure Cosmos DB for PostgreSQL database, and then I go to the PostgreSQL set, and I run this command. Okay, I got an error because I have already enabled this extension, but if you write this command, you will get a different message. And then you can use a different data type, which is called vector, to create a database that will store our vector embeddings.
Okay.
We can create a table. I will use an attribute called file, which will store the file path of the image, and it will be of data type text, and that will make it the primary key. You can use an ID of whatever you want for this case. And the second attribute is my embedding, which is be a vector, and the dimension is 1024, which is the dimension of the vectors that the image retrieval APIs of computer vision generates. And the table is created, and now we can go back to the Jupyter notebook to show you how you can connect to this database and upload your data. Okay, here I load the file path of the image, which is the local file path of the image because the images are in my computer. But if you have your images in an online database, you can use this as the file path. And I have 200 images.
Okay.
Here you can see a pandas data frame that contains two columns. One column is for the file path of the image, and the second column is the embedding. So the next step is to display the images in an image grid in order to see what type of images this collection contains. And this collection contains images related to nature, and as well images of cities and animals and mountains, seas, and things like that. Now, I have an environment file just to load some settings related to my PostgreSQL database. And then you can form a connection string that will be used to connect to your PostgreSQL database. And create a cursor object, which is used to execute SQL queries through Python. And now we are ready to insert our data into the database. There are several methods that you can use to insert data into a PostgreSQL database. I will use a command which is called copy from stdin to load my data. The way I import the data in my database is to first create a temporary table and copy the data to this table. And
Mm-hmm.
then I copy the data from the temporary table to my vector table, taking into consideration possible conflicts that may arise from duplicate primary keys.
Okay.
And now we can accept. So this is just a display of the first 10 rows
Mm-hmm.
of the database, just to verify
Yeah.
that we have successfully imported our data in the database. And now we can actually send a query to this database and see how the vector similarity search work. We
Okay.
have two cases: text to image search, when we use a text prompt to search a collection of images, and image to image search, when we use a reference image to search similar images in our image collection. In the text to image search, we first define text prompt, which is sunset in the sea, and
Mm-hmm.
then we use the vectorized text API of Azure Computer Vision to convert this text prompt into a vector embedding.
Okay.
This is a function that I created that just makes a request to the vectorized text API.
Okay.
And now I can use this vector in a select SQL query
Mm-hmm.
to search for images that are similar to my text vector.
Okay.
And this is the query that you can use to perform vector similarity search.
Mm-hmm.
I want to search my table, the table that I created,
Yeah.
and to find all the top 9 vectors that are similar to my reference vector, which is the text, uh, the vector of the text prompt.
Mm-hmm.
And here, with this operator, I tell Azure Cosmos DB for PostgreSQL to use the cosine distance
Okay.
metric
Mm-hmm.
to calculate the similarity between our reference vector and the vectors contained in the database.
Okay. So you mentioned the cosine sort of thing. I just wanted to ask: is the PG vector support any alternative distance metrics? Like there's cosine, but is there like sine and other kind of distance metrics too?
Yes, you can define another two different distance metric by changing this operator.
Okay.
You can use Euclidean distance, or you can use a negative inner product of two vectors.
Okay. Thank you.
But I'll go with the cosine similarity operator because this is the operator that is used by Azure Computer Vision.
Okay.
Now we can display all the images that were returned by the select command,
Mm-hmm.
and this is the image split. Uh, this is my search query, and these are the top one, the top two,
Mm-hmm.
until top 9 images.
Okay.
And my second example is an image-to-image search. In this case, a user specifies a reference image that want to use in order to search an image collection, and
Mm-hmm.
I use the vectorized image API to convert this image to a vector. I
Yeah.
use then the same select command to search my vector database.
Mm-hmm.
In this case, the first image is the reference image, and the
Mm-hmm.
other images are the images that correspond to the vectors that are returned by the vector checks.
Okay, so it's like if I try to make it in another form, it's like, let's say there's the image and then there's the vector, right? So first name, last name. So first you actually went and searched for first name using the text, for example, saying that this is a Sunset Mountain, and it gives you the images. Now you're actually using last name, which is an image by itself, to search for, find me images that are similar to the image that I provided you, and then using the vector, the distance of the vectors, you're able to find, hey, you know what? Here are the ones that are quite similar to the one image that you have actually submitted.
Yes, in fact, you can use whatever data type you want to search an image collection,
Mm-hmm,
but the only requirement is that you use the same embedding model to convert your search query to a vector embedding
mm-hmm.
as the embedding model that you use to convert your image collection to a set of vectors.
Oh, okay.
You cannot use let's say OpenAI to
Mm-hmm.
convert the query to a vector and then use the vectorized image API to convert an image to a vector
Oh, okay.
and directly measure the similarity between these vectors.
Okay.
For me, that's the demo that I wanted to show you.
Mm-hmm.
So this is some resources that you can use to learn more about the image retrieval functionality of Azure AI Vision
Mm-hmm.
and the vector search capabilities of Azure Cosmos DB for PostgreSQL.
Mm-hmm.
And the last item is a blog post that I have written about image vector similarity search with Azure Computer Vision and Azure Cosmos DB for PostgreSQL. And there are step-by-step instruction on how to call the image retrieval APIs, create the vector database, and how to build the Jupyter notebook that I just showed you in this demo.
Great. Thank you so much, Foteini. I have a couple of questions. Basically, we talked about this model, like, but like, is there other models that are available for Azure for generating vector embeddings?
Yes, I think the most popular model is OpenAI Embeddings model
Mm-hmm.
that can be used to generate vector embeddings for text and documents. And you can use a Hugging Face on Azure to convert your data into vector embeddings. And of course, you can just bring your own model into Azure
Okay.
and perform vector similarity search.
Okay. And I think we talked about this too, like what vector databases are available in Azure. So is it Cosmos DB? Are there anything else?
Yes, I think we talked about this before, but I can repeat all the available options. So we have Azure Postgres database, Azure Cosmos DB for Postgres, Azure Cosmos DB for MongoDB,
Hmm.
uh, Azure Data Explorer, Azure Redis database, and Azure Cognitive Search, which is now
Okay.
in public preview.
So many options for people to choose from. So last
Yes.
but not least, I wanted to ask you is like any call for actions, like we'll put the notes into the links, any call for actions for our viewers.
If you want to learn more, you can go to Microsoft Docs
Hmm.
and search for Azure Computer Vision Image Retrieval and Azure Cosmos DB for PostgreSQL PG Vector Extension. Or you can read my blog that I have
Hmm.
written about this topic, and you can find some useful links and resources and the GitHub repository
Hmm.
uh, to run this Jupyter notebook that I showed you today.
Great. Thank you for Tini. Like I'll share all of those resources in the show notes. Thank you so much. I learned quite a lot about vector distances and everything else, how we could store it in a database and like try to actually get the vision to find out the images and everything. That was very, very fruitful actually for me. Thank you so much.
Thank you too for inviting me. I had a very great time.
Yeah. Thank you for Tini. See you later. Bye.
Bye.